Okay, let me get you guys back up here in five, four, three, two, one. One more time. Good morning. Good morning. Thank you so much, everybody. Welcome aboard, everyone. So we are. Oh wait. Oh no. Hold on. I messed up. You know what? Let's see what happens. I think because the thing was. It just sounded like because I was like 10 yards away from the microphone. Anyway, good morning. There we go. So guys, today's the first day we're going to be doing recordings for our anyone who's absent, or if you go home and forget how to do this, you can watch the video again, watch it with your folks, do whatever it is you need to do. So again, when we're recording, guys, it's not recording anybody's faces. The only thing you're going to see is whatever's on the screen up here. That's what you would see in the video, and then we're not using any last names to protect your identities, okay? So anybody who's listening at home, do you guys want to say hi? That was very meek. Like, hello. So all right, I like that. Okay, when I say teach, you're going to say, okay, I want you to talk to each other. What is your favorite kind of ape, and what do you like about it? And what kind of things do you think apes care about? Why don't you talk to each other, guys? What's your favorite ape? What do you like about it? And what kind of things do you think it cares about? Teach! Okay. All right. Let's see if that's working. I know it's been a year since I've had to do this. Well, maybe hang on. Let me see. Do I have to refresh it? Okay. Oh, see, that's trying to do that. Tusk tisk. Okay, there we go. We're good, I think. No, don't exit OBS. Okay. All right. Those of you who are just joining us, sorry for all the confusion. Here's our warm up. What's your favorite kind of ape, and what do you like about it? And what kind of things do you think apes care about? Let's go ahead and get that going. Spoiler alert. All right, guys, come on up in five, four, three, two, one. What is your favorite kind of ape? Let's see. What is your favorite kind of ape? And I would love to hear that from. Oh, nobody's sitting there at D3 today, but E3's got somebody. Charlie, what's your favorite kind of ape? An orangutan. I like orangutan. How many said orangutans? We liked orangutans. Yeah. I also realized earlier today that to spell orangutan, you take the E off the orange and the H off of Uton of Orange Uton. Right? Because it's Orangutan, which is doubly funny because the orangutans at Hogle Zoo are orange Utons. No, no, no. So it goes Orang, no E, Utan, no H. Orange Uton. All right. I know. Now we'll never misspell them again. Let's see here. Elisa, what's your favorite kind of ape? Orangutan as well. Awesome. 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 Sure. Why not? Awesome it is. Okay. Let's see here. Chad, what about you? What's your favorite kind of ape? Human beings? Sure. We count as apes. We are tailless primates. Absolutely, we are. I'll take it. Absolutely. Like yeah, I like it. Now, what kind of things do you think apes might care about? Let me draw some cards here, just getting some empty seats. There we go. Caroline, what kind of things do you think apes might care about? Yeah, they beautiful. They care about their family. They care about their tribe or whatever their troop is called. They care about their food. There's some other stuff they care about. Anybody else think they might know what they might care about? Let's see here, all the way over here because I'm having trouble with your name. You here in the end. What does it start with? J. Oh my goodness. I was like, I know I've messed it up. Yes, I know it's not Jack. It's James. Yes, James. Absolutely. Home, like territory. Absolutely. I completely agree. Yes, Cormac. the look is the Lorax an ape? He might be an ape. I mean, he looks ape-like, right? He doesn't have a tail, but I mean, are there any other mammals that don't have tails other than apes? Hell, humans are apes. Humans fall into we're tailless primates. We're just the best ones. All right, let's do it, guys. Can I get you up here, guys? Open up your planners. There's no planner page yet because we don't have our planner. So open up your math notebooks. We're going to write down our essential questions. Since it's the 6th day of school, guys, did you know that 6 is the only number that is the sum and product of 3 consecutive whole numbers? Yes. There is no other number in the universe that you can take 3 numbers in a row and add them together, and 3 numbers in a row and multiply them and get it. Which for 6 is even cooler, because with 6, it's the first 3 numbers added together, 1 plus 2 plus 3. And it's also the first 3 numbers multiplied together. 6 is the only number that does this. No one else does. Which at first I thought was less interesting, but the truth is, guys, is that 6 is even more cool, because if I take 3 numbers and add them together, like 8 plus 9 plus 10 is 27, isn't it? 27 can't be written as 3 numbers multiplied together that are in a row. I can say that with certainty. Oh no, 27 won't work. 27 doesn't do it, because I can't take like 4 times 5 times 6 and get 27. No, that's just it. I thought you did, and I was like, well, duh, that's not interesting. But I think this is true for all. You can't use different numbers either. It's weird. Today is Black Ribbon Day. Does anyone know what Black Ribbon Day is? I know, this is like one of the ones that's like actually like a serious thing. It is a day to recognize all the people who were killed by Stalinist Russia and Nazi Germany. Like by 2 extreme governments that just went out of control, right? And so it's like actually a solemn day today. Like, yeah, it's just a day to kind of think about like the magnitude of all those lives lost. On a happier note, you guys got the Pictionary. It is at the circus. The correct answer is trapeze. It was the trapeze. There was a kid in first period who was like, swing, like, what's that circus swing called? He knew exactly what it was. He just couldn't think of the name. It is trapeze. Does anyone think they know that Jeopardy costs a little extra? If you need a passport quickly, pay the State Department for this rush processing, meaning sped up. Cormac? It is, but what is that? I didn't get that one either. Neither did you know what? I asked Mr. McGowan because I didn't know it, and he looked at it and then looked at the answer and was like, "I got it right." And I was like, "Why didn't you say it out loud?" And he's like, "Because I didn't want to." And I was like, "Mr. McGowan, I'm on to you, sir." Charlie, you think you know it? No, I know. I was having a hard time too. It's what is expedited. Expedited, meaning sped up. That's you expedite. I know. Yeah, I know. I believe the X in FedEx stands for expedited. Yeah, like it's supposed to be extra fast. Anyway, the more you know. Da, 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 da. Okay, what's our first essential question? And I would love to get that from, well, I mean, nobody sits at table F or J or I or B. There we go. Haha, Kai, what is our first essential question? Those those are actually letters. So like the first one looks like a N, yes. That's okay. I'll write them down. What kind of numbers do, and it's called a double barred N, a double barred W, which is really fun to say. Double barred W. Try it out. Yay. A double barred Q and a double barred Z, which is like 2 sevens back to back and one of them's upside down, represent, and how do I tell them apart? Well, the numbers that represent them can look very similar. And it's really important for us to be able to look at a number and very quickly categorize it in one of these categories, N, W, Q, and Z. And we're going to talk about that in a minute. And actually, in this class, we're going to add R much later, though. And then when you guys are in 9th grade, they're going to add C. Okay. Underneath all that, guys, let's write a title for today. Got a pencil? Yeah, absolutely. Oh, there it is. Got a pencil? Hey, there we go. You guys are trying. I like it. I like that ape discussion. I think you guys are doing well. Thank you so much for giving this your best shot and making it work, guys. That was a terrible mighty oh yeah. You could do better than that. That was a fantastic mighty groan, though. Nice. Maybe it's because you guys are feeling the groan more on a Monday. It's like nobody really feels like being like woohoo. Except honestly, my son he's 1.5 and he has croup, so I am super excited not to be hanging out with him right now. Like croup, it's a cough that every like baby gets. It's super obnoxious, and it looks. We had to go get tested and all that stuff. He's good, but anyway, let's write down a title for today's notes. Today's notes are number sets. Because there's something we'll be doing a little bit later, we need a quick reminder about Venn diagrams, and especially Venn diagrams that might Gesundheit. Especially Venn diagrams that might have some features that look different. So give me a nice big rectangle, and this rectangle is going to represent all primates. Then you're going to give me two circles inside. Oh, actually, I'm going to make those ovals. Two ovals that don't overlap. Because have you guys ever heard the phrase great ape before? There are great apes. It turns out that apes get categorized into two different groups of animal, right? There are great apes and other apes. I know. It seems terribly rude, doesn't it? These are the great apes. Those are other apes. Those are the apes that are not great apes. And now there's something that's really important that sounds weird, but it'll make a lot more sense. We're actually going to draw an oval inside of great apes because there is a kind of ape that every single one of the ones inside that circle are great apes. And that's apes who habitually wear hats. Apes who habitually wear hats. I mean, not because someone glued a hat to their heads, but like apes that construct and wear hats. Okay? Yeah. How about this, guys? Start raising your hand and telling me a primate, and we're going to put it in this box. Great. What do you want? Humans. Humans, they are primates. Are they great apes or are they other apes? We are great apes. Do we habitually wear hats? We're the only ones who do. Humans. So humans are great apes that habitually wear hats. So every human is a great ape that habitually wears hats. What other apes we got? What are primates? Primates in general. What else we got here? Uh-oh. Your name starts with an L, right? Is it Lucy? Yes, Lucy. Gorillas. Gorillas are great apes, but they don't habitually wear hats. So they belong in this bubble. What else we got? Primates, Cormac. Orange Utahns, orangutans. They're great apes. The orangutan is indeed a great ape. What else? What other primates? What other primates have we got? Yeah, Kai. Chimpanzees are a great ape. They're in here. Chimpanzee. Was that what you were going to say? Gray's got another one, another primate. King Kong? Well, he's fictional, so we'll put him elsewhere. Otherwise, he would be a great ape. And I don't think you could make a hat big enough for him, but if you could, it would be hilarious. Can you imagine if he had like one of those little German hats with the feather in it? It was like hard to take you seriously, friend. Squish. Oh, okay, never mind. Anybody else got primates? They don't have to be apes. They could be any primate, right? Yeah, go ahead. Spider monkeys, right? Spider monkeys belong out here. They have their own group going on, but in our Venn diagram, they don't belong in great apes or other apes because they're not an ape. So they live out here with all primates. Beautiful. Does anyone know? I can think of two more kinds of apes that I would like to put here. Two more kinds of apes. Charlie? Howler monkeys, those would be in all primates. Can anyone think of the other types of apes? We'll be here all day if we do that, right? So another type of ape is a bonobo. A bonobo, Bonobo, bonobo. What's funny about bonobos? Bonobos are basically chimpanzees that aren't violent. They're like, what if chimpanzees were nice instead of terrifying? And if you're wondering, why are chimpanzees terrifying? I would say look it up, but I do not recommend looking it up. It is really unpleasant. And I would like to continue looking at chimpanzees and being like, oh, so cute, instead of being like, you're a monster. Right here, your name is Jane. Baboons are actually, they're other, I also don't know how to spell them. I think it's B-A-1-B-O-O-N, right? I think so. We're missing. Oh, I think we're missing both of these guys. Do we have that? Did we get gorilla? We have gorilla. We don't have these dudes in the middle. Does anyone know what those are? They're not lemurs. Those are called gibbons. And you know what's sad? They're the only ape under other apes. Yeah. There are great apes, and then there are gibbons. And by the way, this gibbon on the right looks like he just heard you say that. And he's like, say that to my face. You want to say that again? Yeah, there's great apes, and then there's you. Anyway, that's how Venn diagrams work there. So I sure won't. I'm at school, and I wish to remain employed. All right, so you guys, it is like way more violent than it should be. It's just like, oh no, why? Okay, moving on, guys. So let's talk about it. The first the first numbers that human beings cared about, we can't be sure, but the first time we ever saw numbers expressed was etched tally marks on a bone, and we think that they might have represented the number of people in a family or a tribe. So when I say teach, you're going to say, okay, talk to each other. What are some reasonable numbers that could have been the number of people in a cave person's family or that person's tribe? What kind of numbers would you use? Just throw out examples to your partners. Teach, teach. 4, very good. Yeah. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Okay. Folks, the numbers you've just given me are called natural numbers. Let's get them. Got a pencil? The kind of numbers that you could use to count members of your family or tribe or group are called natural numbers. They're the first numbers that human beings worked with, and their special symbol is a double-barred N. Start, just popcorn out some of those numbers. 2, 5. Sure, you could have 1,000, right? A big tribe. 10, 3, 7, absolutely. So on and so forth, guys. We could come up with as many numbers as we want. If we wanted to be like, get all kumbaya on it and be like, hey, the world is this one great big tribe, baby. Woo! And it's like 7 billion, whatever, right? Like all these numbers could represent how many people are in our tribe. That's why natural numbers are the set of numbers. And it's weird. When I'm talking about a set of numbers, I put them in what's called curly brackets like that. That curly bracket there, it kind of looks like somebody took like a regular like parentheses and sat on it on the bus. Go 1, 2, 3, 4, 5 to infinity. Onwards forever. Natural numbers go on forever because theoretically you could have any number of people who live in your community, right? If humanity ever makes it to the stars, that number doesn't have a limit, right? Like you just go populate every other planet. Now, guys, there is a number that is conspicuously missing from the natural numbers. I know there's a lot of numbers missing, but there is one specific number that seems to be conspicuously missing. And I have two things I want you to talk to your partners about. The first is this. What number seems to be conspicuously missing from that list? And why do you think that is not a reasonable number to say when you're talking about This is how many people are left in my tribe. Why can you not use that number? Good. I'm glad you're laughing. It's good. That means you got the right idea. Teach. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1? Anish, what number seems to be missing? 0 is exactly right. Do you think you know why we couldn't use that number to describe the number of people in our tribe, Anish? Then who's counting? Yeah. There's going to be at least one, right? You, the one who's counting. And that's why these ancient societies didn't have 0 for a long time. Now, why do you think 0 came up? Does someone think they know why 0 would come up? Right over here. Oh no, now that you've moved over a seat, I've forgotten. Hang on, Jasper. That's true. What happened to those guys? There's 0 of them left. There's actually something that would have come up first, right? There's something that I think would have come up before that. Let's see here. Lucy, no, yes, Lucy. Food. Yeah, when you run out of food, you've got 0 left, right? If you've got 0 bananas, that is exactly what happens. So, got a pencil? The whole numbers, which we denote with a double-barred W, include all the natural numbers and also 0. So we're actually just going to write that as a set. 0, 1, 2, 3, 4, ... onwards to infinity. And we needed it because we needed to be able to say, give me your bananas. I have 0 bananas. Oh, okay. Now here's the point, guys. Is 3 natural, whole, or both? Both. Is 0 natural, whole, or both? Can you tell, is there a number that is natural but not whole? The answer is no. Every natural number is also a whole number because I can get to any number on that first list using that second list. Does that make sense? If a number is whole, it has to be natural. If a number is natural, it's probably whole, unless it's 0, in which case it's not. What numbers do you think came up next? Because at this point, we were able to do a whole lot with this group. But then there was another kind of number that seemed very important. And why do you think it came up? Let me see. Jaila, what's on your mind? Integers, actually, for what it's worth, we are going to put that on the next group, but that's actually not what came up first because there's something a little more pressing, like to an ape, because an ape, what does an ape care about -7 for, right? Like, there's something we can come up with, but it comes much, much later. Let's see here, Cormac? Sure. Why do you think they came up? Yeah. What if there were 5 bananas and 4 apes? You would each get 4, and then up until we had fractions, they just fought each other for the last one, right? Now we can divvy that thing up and be like, cool, now we have 4 1/4 bananas. Yes, go ahead. And I'm just going to say, that sounds like a terrible idea to keep your species going. Now, guys, we're actually going to give ourselves some space here, so don't put anything here, because we're actually going to put something else there, because mathematically that comes first, but conceptually, these ones come first. Rational numbers. Put it on the next page. Rational numbers, ruh-roh, which is a double-barred Q for quotient, has all sorts of things, right? Like 2/3, 5.7, 2.28 repeating, 1 3/8. And by the way, 8. And I want you to actually give yourself a little bit of space because we're going to add some more stuff there. Because the definition of a rational number is a number that can be written as a fraction. So Can you write 8 as a fraction? Yes or no? Yeah. Jane, what is 8 as a fraction? 8 over 1, 16 over 2. Since you can write it as a fraction, it's rational. As long as it's a fraction of, well, this next guy, integers. We'll get more into that in a minute. Jane, but you had a question. Or did you just want to say that? Okay, very good. Excellent. Give yourself some space here because the last one here is integers. Which, by the way, are a double-barred Z. Why a double-barred Z? Well, they were going to be a double-barred I, but that just looks like 11. And then they just put the bars over it, and then it looked like the Roman numeral 2. And then we're like, well, what about double-barred N? Because they're just kind of like numbers. It's like, we already have that. And then some guy from the back was like, yeah, what about Z? Why Z? Because in German, Zahlen is for number. Und Zahlen starts with Z. If you start up shouting, we will use a Z. Hurrah! And there it is. But so this actually brings up, so Jean-Lai brought that up. What numbers are in integers that we have not discussed yet? What numbers are in integers that we haven't discussed yet? Right here, give me the, Jonathan, right? No, what does it start with? Oh, I'm way off. Owen. Owen, wow. Owen, what numbers have we not talked about? Negative numbers. Will you guys talk to each other? Why would an ape care about negative numbers? Teach! Whoa, 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 I need you back in 5, 4, 3, 2, 1. If I'm going to make a fool of myself and go, woo, 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 teach, you got to make a fool of yourself and go. There we go. Let's try it again. Guys, when I say teach, you're going to say, okay, why do you think apes would care about negative numbers? Teach! There you go. Yeah. Okay, can I get you in 5, 4, 3, 2, 1? Charlie, why do you think that apes would care about negative numbers? Yeah, if one guy owns another guy like 12 bananas, he needs to be like, well, now you owe me 12 bananas. If you don't have a number to describe that, it'd be like, hey, give me back my bananas. How many do you need? 12? So wait, you're going to give me 12 bananas? No, you owe me 12 bananas. Well, write that number down and I'll give it to you. Stop it. Stop this at once and give me my bananas. Integers are the whole numbers and their opposites. The weird thing about those is it actually starts with a dot, dot, dot. -4, -3, -2, -1, 0, 1, 2, 3, so on, dot, dot, dot. So it goes to infinity both ways. We've got the negative number, the negative counting numbers, and so negative counting numbers, the positive counting numbers, and 0. Those are your integers. Count. So like -3 is a rational number. -2/5 is a rational number. -5.71 is a rational number, and so on and so forth. Yes, Jane.
So any number is a rational number?
Almost. It turns out that, so in 7th grade math, all the numbers you encounter are rational except 1. Oh no, 0 is rational because you can write it 0 over 1. That's okay. 0 is definitely a rational number. It's, well, no spoilers. I think you guys might know it, but in 8th grade math, you learn about a whole host of them. It turns out that numbers that are not rational are way more common than ones that are, which is weird, right? Let's put this in a Venn diagram to see if we can try to make some sense of it. So let's do another box. And this box is going to represent real numbers. Mm-hmm. All real numbers, which, by the way, in case you're curious, is a double-barred R. That's why it's a Q instead of an R for rational. The R is reserved for the real numbers. All the numbers that we discuss in this class are real. All the numbers you discuss next year are going to be real. All the numbers you discuss when you guys are in 9th grade taking 10th grade math might not be real. Real numbers. So, guys, all the way at the bottom of real numbers are the most basic numbers we know.
natural numbers. So let's write natural numbers and put a circle around it.
What were some examples of natural numbers? Just say them.
5, 7, 29, 38,002.
Right? Those are all natural numbers.
Now, every natural number is also a whole number. So we're going to put an oval around that. And this is going to represent the whole numbers. Notice,
Every natural number is whole, just like all the apes that habitually wear hats are also great apes. Every natural number is a whole number. In fact, there's only one number that is whole but not natural, and that number is
0. So he's the only one in this ring.
and you thought 1 was the loneliest number.
Well, I mean, technically the circle inside of whole numbers is a 0, so.
Oh, there you go. And then outside of the whole numbers, that's where the integers live.
Notice every whole number is an integer. 5 is an integer, 0 is an integer, 38,002 is an integer. Those are all integers. So what kind of numbers belong in the ring by raise of hand? What kind of numbers are going to belong in that ring? Let's see. I'm going to say, oh, great, go ahead. Yeah, like
-8, -7, -4, 100, -21,372,005.
those are all integers.
And then finally, last one. That's the last one you have to draw. This is your rational numbers,
Which are numbers that can be written as a fraction of integers, like
-2/3, -17.4, repeating, -500 and 2/9.
And also positive fractions?
yes, it's true. It's true.
So like 3/8. Thank you very much. I was
So excited about the negatives.
yeah. 5.5, 2.9.
Those are all rational numbers. Somebody actually brought up, wait, but what about 8/4? Can I put that in that ring? What do you guys think? Can I put 8/4 in that ring? I heard yeses, I heard nos. Discuss. Teach, teach. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Can 8/4 go in this ring? Yes or no? I'd say whatever, and I'd say. I'm still hearing some yeses. The answer is actually no. Can someone explain why I wouldn't put 8/4 inside of this ring? Why wouldn't I put 8/4 inside of this ring? Go for it, Owen, because I mess up your name all the time.
So 8/4
Yes.
is just 2.
Yes.
Should be natural.
8/4 would go under natural numbers because 8/4 reduces to 2. And 2 is a counting number. So 8/4 actually, it is a rational number. You're absolutely right that it's a rational number. It's just all the way in here.
And just because it's fun, draw a circle over here to the side. This has something else.
There is a group of numbers that do not fit inside of the real numbers. And in fact, maybe you guys can come up with it. If a rational number is a number that can be written as a fraction of integers, what do you think is true about the numbers on the outside of that ring? What do you guys think? Chad, what do you think? Indeed, poor Gibbons. No, not Gibbons. Cormac? Sure, numbers that can't be written as a fraction of integers. More on that a little bit later. This is something else. Put your pencils down. I'm not going to make you write this, but it is super fun to talk about. You guys aren't going to believe me. So every real number fits on the number line, right? Yeah, so like if you have 0 over here,
like 1.5 over here, negative 3.3 repeating, right? Like every number on that fits on the number line, even the ones that aren't rational that you can't write as a fraction, but we'll talk more about those later. What's weird is, do you see these numbers that are something else? You can fit them around the number line, but they go places like here or here.
They're going into the third dimension.
Yeah. The real numbers live on the number line. The other ones live off the number line. They actually live off the number line. It's weird, right? Okay. So they're not fake. They exist. They're just not real. I know. There's some of the coolest things in the whole wide world. Those numbers that exist but are not real. They're kind of wild. Anyway, yes, Owen.
One of those be like the square root of -1.
That is indeed. So, let's see here, guys. Got a pencil? Notice that it says, is there homework today? Yes, there's a green check mark, but I'm going to give you time to work on it in class. Let me show you what it looks like. It's going to give you numbers like 82, and it's going to ask, go ahead and write this down. Is that natural? Is that whole? Is that an integer? Is it rational? Is 82 a natural number? Yes or no? Yes. So we would check it off. Is it a whole number? Yes, it's also a whole number. Is it an integer? Yes, because I can get to it. It's a whole number or its opposite. Is it a rational number? Because I can write it as a fraction if I felt like it. -8. Is that a natural number? Yes or no? No, so we wouldn't mark it. Is it a whole number? No. Is it an integer? Yes. Is it a rational number? Yes. So you would mark integer and rational. Now, when I say teach, you're going to say, okay, you guys can pull out your Chromebooks, open them up, and work on your self-assessment. That is 1.1 number systems. Give it a try, and here we go. Teach.